Hi everyone, so today we're going to look at arithmetic sequence and geometric sequence. So let's begin by looking at arithmetic sequence. So this is the definition of an arithmetic sequence. It's a sequence in which a constant d can be added to each term to get the next term. The constant d is called the common difference. To find the common difference, you will have to subtract any term from one that follows it. So if we have this sequence 2, 5, 8, 11, 14, we can see that the common difference will be 3. So 5 minus 2 gives you a 3, 8 minus 5 gives you a 3, 11 minus 8 gives you a 3, 14 minus 11 gives you a 3. So the common difference will be 3. If we look at this one right here, we have to find the first term and the common difference of each arithmetic sequence. So the first term is going to be 4. The common difference, if I do 9 minus 4, is going to give me 5. Or you can do 14 minus 9, it gives you 5. For this one right here, we got this next term here. So we got 34, 27, 20, 13, 6, and so on. The first term is going to be 34. The common difference, if I do 27 minus 34, it's going to be negative 7. Or if I do 20 minus 27, it's going to give you negative 7. Okay. So always check to make sure the difference is the same between each term. Let's talk about geometric sequence. In a geometric sequence, the ratio between consecutive terms is constant. So the ratio is going to be called the common ratio. So usually we look for multiplication to identify the geometric sequences. So let's look at this one here. We have to determine if the sequence is geometric. If it is, we have to identify the common ratio. So if you look at the first one, this one is going to be a geometric because we have a common ratio of negative 1. So I'm sorry, the common ratio is negative 6. Okay. So what you can do, you can divide. So if I want to find the ratio here, we can divide negative 6 by 1, and that's going to give you a negative 6. Or you can divide 36 by negative 6, and that's going to give you a negative 6. So basically what you have to do to find the common ratio, you have to divide the terms. The first term, you can divide the second term divided by the first, or the third term divided by the second, and so on. For this one here, we got 2, 4, 6, 8. Well, if I divide 4 divided by 2, gives you a 2. If I divide 6 divided by 4, this one is going to give you 3 halves. As you can see, we don't have a common ratio, so therefore this one is not geometric. However, you know, this would be arithmetic, because if you look here, the difference is 2 here. So 4 minus 2 gives you a 2, 6 minus 4 gives you a 2, so this would be an arithmetic sequence. This is going to be the explicit formula for geometric sequence. So if we have a sub n is equal to a sub 1 plus, times r to the power of n minus 1. A sub 1 is the first term, n is the number of the term, r is called the common ratio. So let's go over this example, which is similar to the one that you have on the PowerPoint. It says that some liquid evidence was found at the scene of a crime. Detectives are performing several different tests on the substance. The amount of substance needed in ounces for each test is given by the sequence. So we want to know if this is going to be is there a common difference or a common ratio. So basically we want to determine if this is going to be an arithmetic or a geometric sequence. So to do that, if I subtract 3 minus 6, it's going to give you a 3. So if I look, if I want to find the difference between these terms, 3 minus 6 gives you a 3, but then if I do 3 halves minus 3, that's not going to give me a 3. So we don't have a common difference. Let's go ahead and look at the common ratio. So if I divide 3 divided by 6, this is equal to 1/2. If I divide 3 halves divided by 3, this is going to give you a 1/2. If I do 3/4 divided by 3 halves, this is equal to 1/2. So as you can see, we have a common ratio. Okay. So this one is going to be, so this is the ratio right here. Because I have a ratio, this will be a geometric sequence. So therefore this will be a geometric sequence. Now we have to write an explicit formula that represents the sequence. So one way to write the explicit formula, we're going to have a sub n is equal to a sub 0 times r to the power of n. So a sub 0 is going to be the first term. First term. So this is going to become 6, because 6 is my first term right here. This is my first term, times ratio, which is 1/2 to the power of n. So this will be an explicit formula that represents the sequence. So if I'm looking for the domain of this function, the domain of this function is going to be all natural numbers. Usually when you work with sequences, the domain is going to be all natural numbers. Natural numbers are the counting numbers, including the 0. So it'll be 0, 1, 2, 3, and so on. So natural numbers, and you have to include 0 as well. The next question or problem, if you have to explain how to get from one term to the next in the sequence, and then you have to define recursive formulas for the end term of the sequence. So if it's an arithmetic sequence, what you can do, you can add the common difference. So let's say I have a 3 right here, and I know that the common difference is 2. So I would add 2 to get the next term in the sequence. Okay. Now this one here, if it's a geometric, it's not arithmetic. I made the typing error. So if it's a geometric sequence, then you can multiply the common ratio. So like in the previous example, if I had a 6, the common ratio was 1/2. So if I do multiply this by 1/2, I'm going to get a 3. If I multiply this by 1/2, I'm going to get a 3/2. So that's how you would find the next term in the sequence if you know the common ratio.